Hello everyone, my name is Aman Abbasi and I'm a master's student in IIT ISM Dharwad, India. Have you ever wondered about this? No, it's empty cup, nothing special in it. But when I put some light from the from a point of top of this cup, do you notice something in it? A cardioid. Why we get this cardioid when we put some light from this point? See, today we are going to explain this and also we're going to find the equation of this cardioid. It is because of the envelopes. See this ring. This ring represents top view of our cup and point B represent source of light. From point B, light rays entered into cup, and from point A we will get our reflected ray. From point B, incident ray will come, it will reach to point A, and from point A it will reflect it sorry, it will reflect it from the wall of cup, and from point A we will get our reflected rays. Okay, this is our setup. This circle represent our cup from top view, and this ray, let's say this point S represent the source point, our light entering into cup from this point. Okay, so and this light ray intersecting with cup at point A. Okay, and this line making an angle of alpha with x-axis. So my goal is to find the equation of this reflected ray. Okay, so let's start it. To find this equation of this reflected ray, I need to find the coordinate of point A. Okay, and this AO is the radius of our circle. As per we know that the radius of a circle make a 90-degree angle with tangent. If we draw a tangent line here, this will work as a perpendicular, and here is our incident ray and here is our reflected ray. Okay, and by the laws of reflection these angles will be equal, and let this angle is equal to theta. Okay, now I have to find the equation of AO. So we know that to find the equation of line we need the angle between x-axis and that line and a point coordinate of a point lying on that line. Okay, then the equation of that line will be y minus y dash is equal to tan theta x minus x dash, where theta is the angle between y x-axis and that line, and x dash comma y dash are the coordinates of a point which is lying on that line. Okay, so according to this formula or this equation, what will be the equation of AO? The equation of AO will be y minus 0 is equal to tan theta x minus r. Why? Because we know that the coordinate of point S is r comma 0. Okay, okay, now I need to find the coordinate of point A. To find the coordinate of point A, what I have to do, I have to put this value of y in the equation of circle. So, and what is circle means their top view of our cup, and the equation of circle is x square plus y square is equal to r square. Okay, at the place of y square I'm going to put the value of y from the equation of line. X square plus tan square alpha x minus r whole square is equal to r square. Okay, so see, this is the quadratic equation, and what we get from quadratic equation, two values, two zeros actually. So for this equation we will get two values of x, because our line this AS is intersecting with a circle at 2 points A and S, and we will get the two values of x is r comma tan square alpha minus 1 tan square alpha plus 1. See what, and into r. See the point S, the coordinate of x is 8 point S is r. So we are not interested in point S, we are interested in point A. So this value will be the x coordinate of point A, and the corresponding y coordinate value will be minus 2 tan alpha r upon 1 plus tan square alpha. Okay, okay, now I need to find the angle theta. See, so actually I need to find the tan theta. Okay, to find a tan theta of a line, what we need two points lying on that line. Like let's say we have 2 points actually, A and O. What is the coordinate of O? Is 0 comma 0. And what is the coordinate of A? We have the coordinate of A. Okay, then tan theta is equal to y2 minus y1 upon x2 minus x1, where y2 x2 comma y2 is a point lying on that line, and x1 comma y1 is also another point lying on that line. Okay, in our case, tan theta will be equal to, tan theta is equal to uh, y2. What is the y coordinate of A? Is minus 2 tan alpha r upon 1 plus tan square alpha minus 0. 0 is y coordinate of origin. And x2 minus x1, x2 is a x coordinate of A, which is 1 tan square alpha minus 1 upon tan square alpha plus 1 into r minus 0. And what we will get? Tan theta is equal to 2 tan alpha upon 1 plus 1 minus tan square alpha. See, if you notice closely, it is nothing but the tan 2 alpha, right? See, we know the formula of tan 2 theta. So this is tan 2 alpha. Tan theta is equal to tan 2. See, tan theta is equal to tan 2 alpha. It doesn't mean that theta is equal to 2 alpha. We know that tan theta is also is equal to tan pi plus theta. See, by the figure, I can clearly say that 2 alpha is not equal to theta, but 2 alpha can be equal to theta plus pi. Okay. Hmm. So I'm considering 2 alpha is equal to pi plus theta. Now take this point as a B. Now in triangle BAS, this angle and this angle, I have to find this angle first. By the in triangle AOS, by the geometry of triangle, we know that what will be the angle A here in triangle AOS, it will be alpha minus theta, and by the laws of reflection, this angle will be alpha minus theta. So I need to find this angle at point B. Okay, so let's consider it x, and the in triangle ABS, x plus 2 into alpha minus theta will be equal to alpha. Okay, now x, what will be the x? If we calculate the x will be equal to 3 alpha minus 2 pi. So now we have x, which is the angle between reflected ray and x-axis, and we know that this reflected ray is passing through the point A, and we know what is the coordinate of point A. Now it means we have the coordinate which of a point which is lying on this reflected ray and the angle between this reflected ray and x-axis. Now we can find the equation of the reflected ray. Okay, then what will be the equation of this reflected ray? Y minus a y, which is the y coordinate of point A, into is equal to, sorry, is equal to tan 3 alpha minus 2 pi into x minus ax, where ax is x coordinate of point A. Okay, so this is the equation of reflected ray. So we have solved the problem, not actually. Yes, where is the cardioid? Actually, this reflected ray is a part of that cardioid. We need to draw many this reflected ray to see that cardio we saw in the beginning of this video. See, this is the final result. This red line, not x-axis, another red line. I am getting this red line from a reflected ray equation I just derived. So for incident ray AB, I'm getting a reflected ray. Okay, for another incident ray, I will get another reflected ray. So let's draw a few reflected rays and see what we will get. Okay. Okay, are you noticing something? We are getting our cardioid, but I didn't draw any curve here. I just draw some straight line which are reflected rays. We are getting this cardio because many reflected rays coming near to each other at the boundary of this cardioid. Okay, and that's the same reason we get a bright spot using magnified glass in sunlight, because all incident rays come together and focus on a single point. So thanks for watching.